Hi, welcome back to Statistics 1. We're up to lecture 22, and the topic today is non-parametric statistics. So in the first segment, I'll talk about the contrast between parametric and non-parametric statistics, and in the second segment, I'll give you a couple of examples. So this lecture is just divided into those two segments. Here in segment 1, I'll give you an overview and talk about what I mean by parametric and non-parametric statistics. I haven't really used that phrase throughout the semester, but we've been using parametric statistics all along. So what do I mean by parametric? Well, parametric statistics are used to make inferences about population parameters. That's where the word parametric statistics comes from. So if you go all the way back to the beginning of this course, the first week, we talked about the idea of drawing random and representative samples from populations so that when we did some statistics on those samples, we could make valid generalizations or inferences to the population. That is, we're trying to use sample statistics to estimate population parameters. That's parametric statistics. We've been doing that all along. So examples covered in this course, we started out with the regression coefficient, so just that B term in the regression model. The regression model R squared. Remember, we could get the proportion of variance explained in the outcome variable by the set of predictors. We looked at group means. We looked at the difference between group means, so I could get a group mean for group 1, a mean for group 2, and do the independent t-test, for example. So in each of these cases, we did a t-test. And then we looked at the proportion of cases distributed across categories in the chi-square test, in the goodness of fit test, and in the test of independence. So there we looked at chi-square. So in all of these cases, those inferences that we made based on sample statistics, they were based on the numbers that we obtained, sure, but they were also obtained, or we also made those inferences based on null hypothesis significance testing, or at the very least, on confidence intervals. And in all of those cases, we assumed a certain sampling distribution. So we used the t distributions, the f distributions, and the chi-square distributions. And remember, each of those has a family of distributions, and the correct sampling distribution to assume depends on typically sample size, or in chi-square, number of categories that you're looking at. So for example, remember here is the family of t distributions. It varies as a function of degrees of freedom, where degrees of freedom is a function of sample size. Here's Fisher's f distribution, where it depended on, this is for ANOVA, where it depended on the number of subjects in a group and the number of groups that we're comparing. And then here was sampling distributions for chi-square that we covered just last week when we talked about the chi-square tests. Now remember that these inferences that we make about a population based on sample statistics and based on those sampling distributions, they're only valid if all the assumptions that we've made along the way hold. And we've made a lot of assumptions along the way. We reviewed a bunch of them in the last lecture. And in some cases, a quick fix is possible. So for example, one of the assumptions that we encountered a lot was the homogeneity of variance assumption in independent t-tests or in analysis of variance. In that case, we could often still use the parametric statistic, the t-test or the ANOVA, just by doing a quick fix, by maybe adjusting our degrees of freedom or by using a more restricted error term. And we could just move along and still use the t-test or ANOVA. However, sometimes it's not possible to just apply a quick fix. And in those cases, we might want to just abandon this parametric approach altogether. And that's where non-parametric statistics comes in. Now, a complete comprehensive coverage of non-parametric statistics is really beyond the scope of an introductory course. That's why I'm just bringing it up here in the last week, just to sort of raise consciousness about all the assumptions that go into the parametric statistics, and to let you know that there are alternative procedures available to you if you can't meet those assumptions. And those are called non-parametrics. So non-parametric statistics, they don't assume that the data or the population that the data are coming from have any characteristic structure. So we're not assuming a normal distribution. We don't have to assume things like linear relationships between the predictors and the outcome, and so on. We don't have to make all these assumptions. So if you find yourself with data that are a little bit more complex, that don't fit all those assumptions we've talked about in parametric statistics, then you might want to look into these alternative procedures. And there are alternative procedures available for all the things that we've covered in this course. So correlation, regression, t-tests, ANOVA, chi-square. We covered all of those with parametric procedures, but there are non-parametric procedures that exist and are available. I just didn't cover them here, and they're not typically covered in a standard intro course. They're typically covered in a course called non-parametric statistics, or maybe a course called resampling methods. So if you're interested in these, I would advise you to look for a course in statistics like that. So for example, for correlation, we don't have to do Pearson's product moment correlation, little r. We could do Spearman's rank correlation coefficient or Kendall's tau. For regression, there are non-parametric procedures just that fall under the umbrella of non-parametric regression. For t-tests, for an independent t-test, the most common non-parametric equivalent is called the Mann-Whitney U-test. For a dependent t-test, the most common non-parametric equivalent is the Wilcoxon signed rank test. For ANOVA, there are several options. So the alternative to a one-way ANOVA, if you want to do a non-parametric procedure, is the Kruskal-Wallis procedure. And if you want to do the alternative for a factorial, the non-parametric procedure is called Friedman's procedure. Also, I mentioned these when we talked about chi-square. If you don't satisfy the assumptions of chi-square, for example, if you don't satisfy the independence assumption, then you should be doing McNamara's test, a non-parametric procedure. And if you have, small expected cell counts, then you could do Fisher's exact test, again, a non-parametric procedure. So to wrap up the segment, we've been doing parametric statistics all along. I haven't really been using that phrase because I just sort of made that assumption at the beginning of the course that we were taking random and representative samples from populations for that explicit reason that we wanted to calculate statistics on those samples in order to make inferences about the population parameters. Okay, so sample statistics are used to estimate population parameters. Once we started engaging in inferential statistics, when we got into the central limit theorem and null hypothesis significance testing, we started doing parametric statistics. That is, we were using our sample statistics to make inferences about the population. Those inferences are only valid if all of our assumptions hold. We've tested all of our assumptions along the way. Sometimes a quick fix was possible, like in the case of the homogeneity of variance violation, or even sometimes when we didn't have a perfectly normal distribution in the outcome, right? We were able to do a quick transformation and then still do a linear regression, for example. But in some cases, it's just impossible to overcome the violations of assumptions that you may incur. So when you do it, my advice and a statistician's advice would be to just abandon this procedure altogether and adopt a non-parametric procedure. And many non-parametric procedures are available. Again, so many are available that it's really beyond the scope of this course to cover them all. But just to show you that there are some available, there are procedures available for all the parametric procedures that we covered in this course. And in the next segment, I'll show you a few examples of non-parametric procedures that are available for some of the more popular tests that we covered in this course, the paired samples T and the independent T. So we'll go through some examples in the next segment.